let's continue our discussion of conservation of matter. Now we're going to talk about molar volume conversions. So we're going to be discussing volume. As a quick reminder, volume is the amount of space that something occupies. So to kick this one off, molar volume is the conversion factor that relates two things. It relates the volume of a contained gas to the number of moles of that gas. Okay, so you can figure the volume of a contained gas from the moles of that contained gas. Okay, or you could go the other way and you can determine how much gas, how many moles are in a specific volume under standard conditions. So what I want to highlight though are standard conditions. These standard conditions are standard conditions of temperature and standard conditions of pressure. Okay, if you modify either of these values, then you're going to have a different volume or a different number of moles. But again, consider a contained gas under standard conditions. 1 mole of any gas under these conditions, so it's 0 Celsius and 1 atmosphere of pressure. That's abbreviated as STP, standard temperature and pressure, with a temperature value of 0 Celsius, which is equal to 273 Kelvin, and a pressure value of 1 atm, 1 atmosphere. Okay, so these are the standard conditions of temperature and pressure. At these conditions, 1 mole of any gas occupies 22.4 liters of space. So 1 mole of gas takes up 22.4 liters of volume. Now, I'll give you a second to go ahead and work these out. I'll assume you've taken that time, and now we'll begin. 1 mole of any gas occupies a volume of 22.4 liters under standard conditions. Standard temperature and pressure are abbreviated as STP. STP values in degrees Celsius and atmospheres are 0 degrees C and 1 atm, respectively. So respectively again means in order. So I would first have to give temperature value and then the pressure value. Now let's finish this table. 3 moles of gas. So 3 moles of gas, I'm going to have the thing I want to cancel on bottom. 1 mole of gas with 22.4 liters of gas on top to get the ending liters. So 3 times 22.4, that's going to be 3, that's 44.8, and then another 22 added to that, it's going to be 72.2, I think, 76. Mental math is not working for me today. 22, 44, 66, 67.2, 67.2 liters. There we go. So again, CST, you won't have a calculator, so you're going to have to kind of mentally do these. Now, 44.8 liters of gas. We're beginning with liters, so our conversion factor has to have 22.4 liters on bottom, 1 mole on top. So we're going to have to take this number and divide it by 22.4. Luckily, 44.8 divided by 22.4, that one's pretty straightforward. This would be 2 moles. Now, 0.5 moles of H2 gas, so now we're being specific about what kind of gas, but it doesn't make a difference. 0.5 moles of H2, so moles are what I start with. I want to cancel 1 mole for every 22.4 liters. 0.5 moles, 0.5 times 22.4, half of 22.4 is 11.2 liters. Now 11.2 liters of CO2. Oh, look at this. I want to cancel liters, 22.4 liters. 1 mole goes on top. And this is 11.2 divided by 22.4, which is 0.5 moles. Now again, the identity of the gas doesn't matter. It's just if it is a gas, then under standard conditions, this is what we have. So 10 moles of O2. So now I have moles that I start with. So the 1 mole goes on bottom, and my 22.4 liters on top. 10 times 22.4, essentially shift the decimal, is 224 liters. So I just want to make sure that you get that idea. Hopefully that was helpful, and we'll move on.